Then E is negative. This plate will be charged with negative, right? But because of the dielectric in between, the charges cannot cross over to neutralize each other. So this plate will remain negative and this plate will remain positive. As long as there is this separating layer and insulating material in between. So in this state, we say the capacitor. Charging a capacitor involves connecting it to the source of current. And capacitors can only be charged up to the potential of the source. Like in this case, if it is a 12-volt source, like a 12-volt battery, you can only charge the capacitor up to this very same potential, not normal. Capacitors can only be charged to the voltage of the source. Then, discharging a capacitor involves connecting an external load. You want to connect an external load. Let's say, you connect an external load. You open up this, you connect that. What's going to happen is current is going to flow through the external load. The charges, they now find the path. I think we know from our exercise, static charges. Static charges, light charges, light charges. So by connecting the plate through an external circuit through a load, the potential between the two plates is such that the unlike charges will attract. So we are going to have charges migrating through an external circuit in like if the external load is the lamp is going to flash, the lamp is going to flash, momentary flash, because the charge in there is not much. Sometimes capacitors do not store much charge as opposed to like rather is compared to battery cells. Battery cells can store so much charge, but capacitors store small amounts of charge. So a capacitor can only store so much charge, very little charge, right? That little charge, when discharged, can cause just a momentary flash. No construction in capacitor. We're going to place a dielectric in between. When connected across the battery, one plate becomes positive since it is connected to the positive, the other one negative since it is connected to the negative. No exchange, no capacitors. The standard symbol representing a capacitor, the ordinary capacitor, that is something. Two lines that are parallel and equal in length. This represents capacity. We also have other variables, other capacitor variables, capacitor varieties. Like we have something that we call a variable capacitor. A capacitor is with variable capacitance. So this is a variable capacity. Its capacitance, you can adjust it to absorb more charge. You can adjust it to absorb less. Those are GT variable capacity. Then we also have another version of the capacitor. They call it a polarized capacitor. So a polarized capacitor, anyone who knows what positive actually is. So you are symbol very same as IAC, then you are positive side. A polarized capacitor is connected according to a stated polarity. One connected the wrong way around, it may explode. So polarized capacitor, the symbol representing the polarized capacitor So I am asking symbols are not using a capacitor or circuit. But whatever, all capacitors are meant to store charge and discharge it. All capacitors are meant to store charge and discharge it. So, from a vanity diagram, so, something like